All right, now, so you're going to get more practice graphing transformations, and I may leave it as an exercise. You had a lot of practice with quadratics, so you should be able to do this one on your own, as well as this one. These are affecting the y values, so maybe a few. If I just remind you, when you make, let's say, the table for the original function, where the original function is y equals x, then you know, let's say minus 3, minus 1, 0, 1, 2. The y value is simply whatever x is. And if you look at the transformation function, this is your a value, so that means you're going to multiply all the original y values by 2. And this is your c value, so you're going to shift all of the original y values down by 1. So that means the x values stay the same. So minus 2, minus 1, 0, 1, 2. And then you have here negative 2 times 2, so negative 4 minus 1, you've got negative 5. Negative 2 times negative 1. So you've got negative 3 here. And you've got negative 1. And if you're not sure, work these out, right? And then this is 1. 4 minus 1 is 3. And then you would graph these points. So you can see that the whole line is vertically stretched, and it's also shifted down 1 unit. So graph this. I'll pause. All right, so once you have the points, you can take your ruler and join them. And keep in mind that it does stretch forever in both directions. So this would be now your transformed line. So y equals 2x minus 1. Do the quadratic. I'm not going to even graph that. You're going to try it on your own. And if you have a question about it, you can let me know. Right now you have here your k value. Your k value is 0.5, which is the same as 1 over 2, which means your x values are going to be, the graph is going to be horizontally stretched by a factor of 2, because remember, you flip it. And this is your d value, and it's going to be shifted to the right 3 units. So if you look at your original values for f, where f of x is x cubed, so you've got a point here, minus 2. The y value is minus 8 because it's minus 2 cubed. And then when x is minus 1, y is minus 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. Now if I write the transform function, what you're doing is you're going to transform, in this case, the x, it's only the x values affected. It's going to be 2 times x, and then plus 3, because it's shifted to the right 3 units. So then we've got here minus 2 times 2 is minus 4 plus 3. We've got minus 1. And your x value is minus 8. So if you look here on the graph, if this was your original point, your transformed point is going to be right here. And then minus 1, we've got minus 2 plus 3 is 1, and the y value is negative 1. That's right. So the transformed coordinate then would be 1 minus 1. And then we've got 0, 2 times 0 is 0, plus 3, so we've got 3 and then 0. So at x equals 3, y is 0. So you can see the shape is remaining the same. It's just a bit stretched out horizontally, and it's also shifted to the right by 3 units. So when the original x was 1, the transformed x will be 2 times 1 is 2, plus 3 is 5. And the y value stays the same. So we've got y. X is 5, y is 1. And then finally, the original x is 2, so we have 2 times 2 is 4, plus 3 is 7, and then 8. So 5, 6, 7, 8. So let's see how my drawing goes. I'm going to do better from here to here, I think. It continues on. And continues on. So not bad. All right. So now work on the other ones. And like I said, if you have a problem, you're going to let me know. So there are 3 more on this page that you'll have in your handouts. And 1 more on the following page. And I think I've also included the photocopied homework pages as well. So let me know if you have questions. Thanks.